Welcome and hello. This is a video exercise in HEC ResSim, and in this exercise, I'm going to be covering ensemble computing. Ensemble is a particular type of alternative in ResSim, and it's used for running simulations that include multiple scenarios or multiple data sets, and also used for analyzing those results as a total and drawing conclusions by looking at those results together. We're going to do that in this exercise. So let's get started. Here we have ResSim up on the screen, and I'm using ResSim 3.3, and I have the watershed setup module selected from the dropdown. So let's start off by going File, New Watershed. I'm going to call my watershed video 35, and then select your directory that you want that watershed to be saved to. Select the units and then your time zone. Click Apply and then OK. And then, all right, our watershed has been created. I'm going to go ahead and zoom in a little bit and select the stream alignment tool here on the left tools menu. Hold down the control button and then single left click on the upstream end of the stream alignment. And then a couple more clicks. Just before your last click, let go of control, click, and then it's going to ask you to give the stream a name. So I'm just going to call mine stream 1. It's not too important for this exercise. Next, I'm going to select the computation point tool here on the bottom left of the tool menu. This is the black dot. Hold down Control, single left click, and then give your computation point a name. I'm going to next select the reservoir, hold down Control, single left click, and then let go of Control. Click again on the downstream end of the dam, which would be the actual dam face, and then give your reservoir a name. Call it Reservoir 1. And then one computation point downstream, just for good measure, CP4. All right, watershed configuration editor. I'm going to go configuration new. I'm going to create a config here. Just call it config 1. Select 1 hour is fine. And then apply and OK. All right, I'm going to go File, Save Watershed. Next, I'm going to select the Reservoir Network module. And the first thing to do here is to create a network. So we'll go network new. I'm just going to call my network 1. And then what's important here is to select the configuration here that you just saved, whatever you named it, and then new. So here is our network. We need to connect that though. These junctions need reaches between them. So select the reach tool here on the left. Going to hold down control and then click and then let go of control, click again. And I'll draw a reach downstream of the reservoir as well. And OK. All right, so we're all connected. I'm going to go ahead and save that network. Next, I'm going to go edit and then junctions. I want to add some inflow to this upstream junction, CP1. So I'll select CP1 and then select the local flow tab. And then I'm just going to call it something generic but obvious like inflow at CP1 with a factor of 1 over here. Make sure to use the top row of this table. Apply and OK. So we have a little blue dot representing inflow at that CP1 junction. We're going to assign that inflow a little bit later. So just hang tight there. Let's go ahead and edit the reservoir real quick. I'm going to select the reservoir tool, right click and edit reservoir properties. Another way to do the same thing is just to go up to edit and then reservoirs, then make sure you have the reservoir selected. It's our only reservoir here, so it's the only one that's could be selected. Here's the pool. I'm just going to right click and paste. I have the pool data saved in my clipboard. So here it is. Our pool goes up from 0 to 100,000 acre feet, and the top elevation is 1,500. So when I go over to the dam here, I'm going to type 1,500 as the top elevation. I'll just make up a dam length here. And then I'm going to add a controlled outlet and then paste in the data for that. This is the max capacity through that outlet per gate based on the water surface elevation. So if I make it, say, 3 gates instead of 1, then the total increases by 3. All right, so I'll apply that. And then next, let's go over to the Operations tab. This is where we go Operations New to create an operations set. I'll just call it Operations Set 1. Okay. Now I'm going to add the top elevation of each of these 3 zones. Flood control is going to be at the top, so 1,500, and apply. Conservation is going to be 1480. Apply, and then the inactive zone, the top of the inactive zone will be 1400, and apply. So if I double click on the plot here, I can see the cross section. We have air, flood control, conservation, and inactive. All right, next up, I want to create a couple of rules, and this is the focus of this exercise is not on zones or rules per se, but you'll see why this is a good rule to have just for the simulation to look better. I'm going to do a min 2500 CFS. This is just the name of the rule, so I actually have to input that data. Controlled outlet, release function, that looks good. I said min, and then this will be year round, so we'll just say January 1st, 2500, apply. I'm going to add a maximum of 3800 CFS, so let's go with max 3800, controlled outlet, release function, define date, and 3800. Okay, and then maximum here. Apply. All right, so add rule to all zones, add rule to all zones. Okay, and apply. All right, next we need to create an alternative. So alternative new. I'm going to call this base for a base case alternative. First, I'm going to run create a standard alternative, and then we're going to run an ensemble alternative with multiple records from a data collection, not just a single data set. That's the direction we're going here. So here we go with base, and I'm just going to keep it at standard for the alternative type. But as I mentioned, ensemble will be used later in this exercise. All right, so 1 hour time step will work good. Everything else here will leave the same. Operations, we're going to go operation set 1 and then look back. We're going to start the reservoir at 1480 feet. That's the guide curve elevation, or the top of the conservation zone. And then for the initial release for the look back period, let's go with 3000 CFS. And you will see why I chose that in just a moment. Okay, so I'm going to save the alternative. The last thing we have to do for the standard, this first alternative, that's just the standard type, and run control standard type, is to assign the inflow to CP1. We haven't created an inflow yet, and what I'm going to do is create a bunch of inflows. I could find the inflows online, but it's almost easier to just synthesize the inflows myself, creating a time series using a Python script in DSS View. So that's what I'm going to do. So I've opened up DSS View here as its own standalone software package, not part of ResSim per se. And I'm going to go ahead and go new version 6. Version 7 may work for you if you're using ResSim 3.5 or something later, but I'm on 3.3, so version 6 it is for me. Next, what I want to do is navigate to my watershed directory. So I'm in video 35. That's just the name of my watershed, but your watershed's probably something that makes more sense. Now I need to give the DSS file a name, so I'm going to call it time series data.dss and create. Okay, so this file has been created. What I want to do is go ahead and write a script. So I'm going to go Tools, Script Editor. All right, so I got the script editor open, and I've got a few scripts I've already written here, but I'm going to select this HEC DSS view directory on the far left, and then New Script. Up at the top, I need to give the script a label, so I'm just going to say Create Time Series Data Ensemble. And then we don't need any of these checkboxes checked. I know this is an exercise about ensemble computing, but this is part of doing everything from scratch. All right, so I'm going to just paste in the code and explain what it is. So this is the entire script. And what we're doing here is importing some libraries. This function right here gets the mean value. The mean starts at 3000, which is our initial release, goes up to 4000, down to 2000, up to 4000, and then back to 3000. So just think of it as kind of like the letter M in terms of its shape, and I'll show you what that looks like a little bit later. But that's all this function is doing. Okay, next I'm going to have 75 different data sets that I'm creating. This is going to be for January 2024 on an hourly time step. So we have, so it's going to loop from 0 to 74. This is a string that's padded to 6 decimal places, and it's used for part F. So down here, when I'm actually creating the file path, it's going to say part F is C colon, and then that 6-character long ID, which is going to be 000001 for the first one, and then 2, and then 3, and so on. And then, of course, a pipe, and then the actual part F. Let's see, what are we doing? For the very first record, I'm setting the flow to 3000. But if it's not the first record, which is else, then the flow is going to be calculated using this equation here, which is based on the mean value, rho, which is the correlation coefficient, the previous value, and then some random noise factor, which is based on the standard deviation. So I'm not going to explain everything here, but by all means, pause the video and read it for yourself. Let me scroll down to the bottom so everyone can see that. Basically, I'm creating this time series container, and then I'm writing it to the DSS file. So this should be the same file that is right up here, but make sure to use slashes instead of backslashes. Okay, so I'm going to go ahead and run that and see if this works. So let's do a before and after. Here's the before. There's no records in my time series data.dss file. And let me just refresh the catalog. So yeah, nothing there. So here's the script, and I'm going to run it. And it's got an hourglass. Okay, something happened. Let's check view, refresh catalog, and awesome. So we've got our records from 0 to 74. That's great. Let's go ahead and take a look at one record. So here is the hourly flow. That is just one of 75 different time series datasets we're going to use when we actually run the Ensemble compute. In fact, this very first record here is probably a good one to use for our standard. So we do need one record for the standard alternative, and then all 75 for the Ensemble. If I plot all 75 together, let's do that. Here is what that looks like. Okay, let me lose the legend because that's taking up half the screen. All right, so now you can kind of get an idea of what that average value is like, because the time series are kind of starting at 3000, 4000, 2, 4, and then 3000, like I said, in M shape, just to kind of give the inflow a little bit of variation and not just a constant number. I'm going to go ahead and close that. We can head back to our alternative now in ResSim. I'm going to go to the alternative now. And here is my inflow CP1. Remember, this is the base alternative. That's just standard. So I only need one record. I'm going to select DSS path and then go open up that directory, time series data.dss. Okay. Right now I have the view set to condensed group collection. So this is what I'll use when selecting the collection for the Ensemble alternative. But right now, path name parts is fine. I just want to select the first record. That'll work fine. And then click this set path name button. So when I click that, close this now, that reference was made over in our alternative. And I'm going to go ahead and hit save. All right. So we can close the alternative. And let me save the network. Now go over to the simulation module. Let's go simulation new, and I'll just call this sim1, and this is for the month of January 2024. So let's go Jan 2024, and then the look back will be on the first day of the month. It will end on the 31st, on the final hour of the month. And then let's see, so we're going to start the simulation on the second hour, but then the look back will start on the first hour. Okay, and then I'll check the checkbox down here for my base alternative. Click OK. All right, so the network popped onto the screen here. That looks good. And then compute. All right, so this is pretty standard. This is not Ensemble yet, but I just want to take a look at the results here. All right, great. So it looks like we did bump up against the HEC release of 3800 a couple times, and then as well as the lower bound, the minimum of what, 2600 was it? And we should probably have a little bit of variation, a little bit of deviation from the guide curve elevation. But again, this is really zoomed in, so this is like less than a foot. All right, that looks good. All right, we're ready to go ahead and create the Ensemble alternative and run that and look at results. First thing I want to do is just go ahead and create a new trial based on that alternative. So I'll say new trial. And what I'd actually like to do is call this standard. So I'm not actually even going to make any changes to this one, but what I'm going to do is just have it there so I can compute trial one versus trial two if I wanted to. New trial. This is going to be the ensemble. Okay, thank you. And then ensemble, this is the one we're going to edit. So I'll right click, edit, run. And now in the alternative editor, here I'm going to select ensemble. Okay, that looks good. Now for time series, I'm going to select our CP1 junction and then click select DSS path. Now we want to change the view to the group collections, and here they are from 0 to 74. And then I'll select that record and then click set path name. So that has been assigned over here to our CP1. So I'll go ahead and hit save. Now over on the ensemble tab, if I wanted to run them all, I would just do an asterisk here. And if I wanted to run it fast, I would check this checkbox. I'm a little bit curious how much faster the checkbox for multi-thread compute works. So I'm going to try it first without checking the checkbox. And then if I only wanted to run like one or two or three specific value time series data at a time, I would just type them in like comma separated values. So if I wanted to like just do the first three, it would look like this: 1, 2, and 3. I believe I can also use a dash, but the user's manual kind of talks about that. All right, so let's go ahead and just run those three and see what happens. So I'm going to save and then OK, and then run ensemble. OK, and yeah, I had this problem. It skipped the iteration because the record was missing. And this is the same DSS problem that's been kind of persistent forever, with me at least in 3.3. What I need to do is save those dataset records we generated using the script into the simulation itself, this base or Sim1 simulation. So hang tight. Let's go over to not the script, but yeah, these records here. So I'm going to select all, and then I'm going to go edit, copy to. Now I'm in the main watershed directory. Where I want to put these is in RSS and then sim1, that's the simulation directory. And then from there, I want to put that in simulation.dss file. So I click open. It says they already exist. I'm not so convinced myself. And it's copying right now. 75 records. So okay, there they are. We're good. All right. Well, if they were there before, then it shouldn't work. But since it's now working, then I don't think they were there before. Here we go with our results. So it ran all three. Here's member 0, I believe is the first one. And then where it's calling member 1, this is the second trial. And then member 2 is the third. All right. So let's go ahead and look at the results here. Okay. All right. So ensemble computing really isn't meant to only be used for 3 records, but probably more like 20 or 50 or 500. Because these lines we're seeing represent the max, median, min, and also 25% and 75% of the data. So let's go ahead and do that because the individual records we can't really see. They're very faint lines that are almost transparent. Let's change it up here and add all the records. So the only thing we'd have to do here is change this to an asterisk. It should run all 75 records now. Save, load. I'm actually going to use my stopwatch to time it out as well because now we're running 75, but I'm not doing that multi-threaded option checkbox. And I just wanted to kind of see how it compares. So, okay, I got the stopwatch ready to go. And let's compute in 3, 2, 1, go. Okay, so this is pretty fast. I would say it's going to take maybe 20 seconds. And done. Okay, so 19.8 seconds on that one. And let's go ahead and look at those results. All right, so I'm going to take a look at the reservoir data first. And yeah, this is awesome. Okay, very cool, very cool. Let's take a look at the top first. The individual results you can barely see because they're these very faint green lines that are very small and thin and semi-transparent. But the lines that you are seeing that are darker and like dashed is the maximum up here. And then the solid line is the median, I believe. And then the bottom line is the minimum. And there's also these longer dashed lines, which I believe represent 25% percentile and 75 percentile as well. So we can just take a glance at this and see like, yeah, we have maximum, minimum throughout the month, and pretty satisfying, I think, especially when we have 75 records, which could have been 100 or 1,000, to get a quick glance at statistics and distributions, if you will. I'm going to go ahead and zoom in on this top plot one more time, and let's just go ahead and zoom in right here, for instance. Okay, so it zoomed in on the bottom too, but that's fine. Yeah, so you can see the individual lines. So we're looking at January 6th and 7th here. We have the mean is increasing, 75% is increasing, the max is increasing as well. We can, of course, pan over. Okay, the bottom plot is the release and the inflow. The green, there's actually a kind of a green corridor here between 2600 and 3800, and that's because the release cannot exceed those values. And then the black or dark blue line, whatever you want to call it, is the inflow. So we have the minimum, the maximum, the median, the 25%, and the 75% on both the inflow, which is black, as well as the release, which is green. It could be kind of busy, and I'm not so interested in the inflow in this analysis, so I'm going to look at just the release in green, but to remove the inflow, I'm actually going to just take a look at the plot of the downstream reach, which should be the same thing. Yeah, it is. So this is the same thing, but it's zoomed in, so it doesn't quite look the same, and it's removed the inflow data that we saw in that previous plot. And we can see like this solid line here is the mean. This one's the mean, the 75%, and then along the top is the maximum flow. And then it kind of comes back down here. I'll zoom in case what I just said isn't really obvious. Okay, yeah, so this is zoomed in quite a bit, and the median, the 50 percentile right here I'm tracing it out with my cursor. It's kind of slowly moving its way up. This right here is 25% moving its way up, and then 0%, or I should say the minimum release is still along the bottom of, is this 2600 or 2500 CFS? I'm sorry, 2500 CFS. But if I scroll to the right, I believe the minimum increases. No, not really. Not really. Still down there. Okay. Interesting. So I'm going to zoom out. Okay, I've zoomed out quite a bit. And we can tell in the middle of the month when the average flow is down to 2000, then it looks like the maximum and the minimum are right there, releasing 2500 CFS, which is the minimum release rule. So if I had made, I could have changed the rule to be a little bit different. We would have seen some different results, but you can see the general trend of the darkness of the lines goes from 3000 up to the max, and then somewhere around January 8th, it comes down to the minimum around from the 14th, and then it goes up again, and then starts coming down again. So again, we're not looking at any one particular data point here. We're really looking at all the data combined and then some of these statistical series data that's been added in by ResSim. All right, well, that was it for Ensemble computing. The last thing I want to do is just run the same simulation using that multi-threaded option and just see how much faster it is than 20 seconds. So let's go ahead and do that and then call it good. So alternative editor, use multi-thread, and then save. Okay. And let me reset. Ready, set, go. Okay. Not much faster. It's running. Done. Okay, so it was 14 seconds. It was a little bit faster. 12 threads, you'd think it might be a little faster. All right, all good. So that was it for our example here using Ensemble computing and HEC ResSim.